All right, I know Mondays everyone's always kind of trying to shake the cobwebs off, so it's always good to kind of revisit where we are in the course. This is Module 6. This is week 2 of Module 6, Personal Housing Alternatives. Last week, we had a beginning discussion centralized around credit scores again, kind of like a refresher and how they impact housing decisions. We looked at the fine print of a mortgage bill, and then we had an out-of-class assignment for Wednesday, which was renting versus buying, and that worksheet was provided along with a couple of video series for you to look into. To do that assignment this week, we're going to dig into the math side of this conversation. So we're going to learn how to calculate a mortgage payment using the time value of money. We're going to do a couple of practice problems just determining payment. Then we're going to look at how to calculate an amortization schedule. And then we might do a practice problem or two doing that. And then once you get good at that, I'm going to throw a curveball at you and explain to you the difference between a fixed mortgage payment and an adjustable rate mortgage, and show you how to do all those things again with an adjustable rate mortgage, because it is very different. And a lot of folks who opt for these adjustable rate mortgages have no idea how their payment is calculated, and I want you to know how to do that before you leave this class. So that's what we're going to be doing this week. Before we hop into that, you will need Microsoft Excel for today. If you don't have access to it, then you'll need to follow along. Or you can use a calculator, and if anyone is using a calculator, just let me know and I can kind of walk you through how to do that. But hopefully you're using Excel, because when it comes to the amortization schedule, it's much more visually pleasing to be able to see, the whole schedule from one point of view, although there is a built-in amortization schedule on EA2 calculator for those of you that have it. It's there, but knowing how to navigate it is a little tricky. Okay, are there any questions before we get started? Okay, well, let's hop over to our slides for this week. And I always show this, but it's just so that you can see the beauty that is a smart calculator. So this is the algebraic formula for calculating a mortgage payment, and I show it to you only so that you can appreciate what I'm about to show you, which is how to use a smart calculator to solve this problem. But just know that, a long time ago, before Excel, before the BA2, this was the level of math that you had to be able to do to solve this problem. But for us, it's not going to be so bad. Okay, so that's the only reason why I throw that in there. All right, so I like to start really simple. So to kind of get back into the groove of working with the time value of money, I actually like to give a practice problem that doesn't deal with mortgage payments just yet. I just want to deal with like a typical loan. And that way we can kind of get refamiliarized with the time value of money. I know you used it a little bit in the automotive chapter. It's going to some of the same functions are going to be used again in this chapter, but then we're going to make some modifications and learn a little bit more about what we can do in Excel. So this first problem says you have borrowed $30,000 for 10 years with monthly payments at a nominal interest rate of 9%. How much of your second payment is interest? Now, that's interesting. I'm just going to copy this really quickly, and I'm going to hop over to a blank document. So this is just a blank workbook. Nothing's pre-made. And I've learned this semester, because I'm not used to having to do this on a virtual session, to go ahead and make some of these modifications so you can see. Let's see. Yep. There we go. Hopefully everybody can see that. How's that looking? Is that legible for everyone?
Yes, I can see it.
Okay, good deal. So as you remember from the last module, the first thing that we want to do is to define our variables, right? We also called this our data table. We want to build a data table. And with the time value of money, there's 5 very important variables that we have to consider. So it's N, which is the number of periods, right? A periods, compounding periods. There's I over Y, which is our interest rate. There is PV, which is the present value. There is PMT, which is our payment stream or our annuity. And then there's FV, which is the future value. And these are the 5 most common variables that we deal with when we're talking about the time value of money. Okay, so the problem states that we have borrowed $30,000 for 10 years. We're using a monthly repayment with a nominal interest rate of 9%. Okay, so just anyone want to tell me what they think that 30,000, where it goes if we borrowed the money? That's right, Tristan, it's present value. And since we are the borrower, it's also positive. Remember those positive negative cash flow conventions for the function to work? Certain things have to be positive, certain things have to be negative, and they represent inflows and outflows. Well, this represents a positive value because it is an inflow to the borrower. The borrower receives that money, okay? And it says for 10 years, so right now I'm just going to type 10 in for N, and I'm going to label my units, okay? So 10 years, $30,000, okay, with monthly payments at a nominal interest rate of 9%. So does anybody remember what this vocabulary word means, nominal? What does nominal interest rate stand for? Anyone remember?
No.
Nope. Nope, it's not the best. Nominal is a fancy word for a type of interest rate being quoted relative to time. It's okay. The nominal interest rate is just another way of saying the annual percentage rate, okay? Or shorthand, APR, okay? But you might remember from our last module that when we are using the time value of money, what interest rate do we have to seek out in order for this function to work properly? Do we always use the APR? So in this
No.
case, the APR is 0.09, which that's just 9% decimal form, right? But when we're trying to fill this data table out, what do we have to do? Or I guess a better way to say it is, what question do we have to ask when we're looking at the interest rate? That's close, Tristan, not quite. You're on the right track, but you're going the wrong direction. Exactly. We have to divide by 12. Now, does anybody remember why that is?
Well, because it says monthly payments.
That's right. So we quoted an interest rate on an annual basis. So this is where having a whiteboard would come in really handy. So if you imagine a timeline where we borrowed here, okay, and we'll go one there first. So we borrowed here, and we're paying this loan back, and we're quoted an interest rate that tells me how much interest is accumulated across this 1-year period. However, I'm making monthly payments, which means interest is actually being compounded on a monthly basis. So if I'm given an annual rate, but I have to calculate interest on a monthly basis, and I must convert, right? I must convert that annual interest rate to a monthly interest rate, okay? And M is just a variable that tells me how many compounding periods there are in a year. And I use that for one reason. I use it to help me do the math to modify this rate here. So you'll see watch what I do here. So now that I've defined those two things, I can say equals. I can grab the annual rate and I can just say divided by the compounding periods per year, right? So there's 12 months in a year. And then when I hit enter, I don't have to worry about rounding because Excel is handling the calculations for me. Now it's showing, it's showing 0.0075. I'm not sure if it'll show more. Sometimes, it could be a really long decimal, and that's what's so neat about using Excel is sometimes, no matter how long the decimal is, it's going to give you the most accurate number there by cell referencing. So we've defined our interest rate. We have defined our principal or present value. Okay. It says how much of your second payment is interest. So we know that we're looking for payments. We know that that's the missing variable here, right? So does anybody remember when we're dealing with a loan, what is we hope? What is the future value we hope when we borrow? That's right, Tristan. We hope that it will be zero because if everything goes according to plan, we will have paid that loan off. Okay. And so it looks like we have 4 out of 5 variables defined. However, there's one that still needs some modifying, isn't there? Anybody see it? Anybody see there's a variable that still needs to be changed in order for this to come out right? If you don't change this variable, you will most definitely get the wrong answer. That's right. What do we have to do to the 10 years? What do we need to do there? That's right. We have to modify our N to account for the fact that we're making monthly payments, not annual ones. So if I want to get my 10 years into the right units, I would need to convert to months, right? And so what do I need to do to that 10 there? Exactly. We want to multiply that 10 by 12. So what I'm going to do is I'm going to say equals 10 times, and then just cell reference my M over there. And now I have everything defined accurately. So I know that I'm going to borrow $30,000 across a 10-year period. However, in reality, it's across a 120-month payment period. And my monthly interest rate is 0.0075. I got that by taking my APR, which is my nominal rate, and I divide it by 12 months to get it a monthly rate. This is also known as the periodic rate. So the monthly rate is also referred to in finance as the periodic rate. Okay, and that's because it is the interest rate applied during each pay period. Periodic rate, right? Interest rate period, periodic rate. Hopefully that helps you remember that. Okay, and so now I truly have 4 of 5 variables accurately defined, and I get to use Microsoft Excel to compute that last one. So that remember that formula I showed you at the beginning of class. This is where we get to skip that formula, skip all that algebra, and we're literally just going to type in equals payment, PMT for short, and we're going to open our parentheses, and this is why we do what we do. So we have predetermined all the variables that are necessary to use this formula. which makes it so much easier because now we can just cell reference all of these answers that it's asking us for. So when it says, what is the rate? We just click. We're just going to click on that cell and hit comma. It says, what is our number of periods? N per is number of periods. Well, we're just going to click, comma, oops, comma. What's the present value? Click, comma. What's the future value? Click, comma. Then there's no mention of interest being compounded at the start of a period, and anytime that is the case, we just default to the end of period. So we just always select 0 unless otherwise told to change that. So that last option there is always going to be 0. They have to be in the order that the formula is asking them for. And you'll notice that as you use these time value of money formulas, the order is slightly different. The reason why I present the variables in this order is because this is the order that they are shown on a BA2 calculator. So anyone who's using a BA2, they're seeing this in the same order as they would on their calculator. And I just do that to be courteous of any calculator users. When it comes to defining your variables in Excel, no, they don't have to be in any particular order. You just want to make sure that whatever you're solving for, that you're answering it in the appropriate order. So if you're solving for payment, you need to make sure you're giving the variables in that order. But what if you're solving for present value? What if you have a problem where it gives you everything that you need to know except the original loan amount? Then you'll notice that the order changes. You see that there? Or let's say that you're looking to see how much of a loan will be left after a certain number of payments, but not the very end. Well, then you might be solving for future value. And so if you're doing that, then you'll notice that the order changes again. So it's just very important to, when you type in your formula, to pay attention to what variables you're being asked for and make sure that you're cell referencing the correct ones. But the order in your data table does not matter. Now, remember what I told you. So this is an actual algebraic function that we are determining. And since it's an algebraic function, we have to respect the positive negative cash flow convention. So because we had a positive cash flow, an inflow of $30,000 at the beginning, and we know that we're paying it off by the end, the reason why Excel reports a negative value for the payment is not because it's negative, it's because it represents a outflow of money. So it's negative in the sense that we are making those payments. And if we're making those payments, that is money that is coming out of our pocket and flowing towards the lender. And so it represents a negative value simply because we're making that payment. It could be the other direction if we were the lender. Okay, so if we put $30,000 in the bank, right, as an investment, and this problem was exactly the same in every way, and we were going to receive monthly payments from the bank, of interest plus a little bit back, right, at 9% interest year over year. The one thing that would change is we would make this negative because it would be an outflow, and then this answer would be positive because those would be inflows to us as the lender to the bank. Okay, so just understand that that's why these numbers always has to be a positive. There always has to be a negative. You just have to ask yourself, is it an inflow or is it an outflow? Now, when you go to take like a quiz in Blackboard, you don't need to enter any answers as negatives unless it tells you to. Normally it won't. So one thing that I tell my business finance students to do is, if you don't like seeing that negative, if it really trips you up, you can just put a little minus sign in front of your formula and hit enter, and that will not impact your formula at all. Your formula will still compute accurately, but it will produce a positive answer because it just reverses the sign of your final answer. So hopefully that's a neat little trick that you can do there. Okay, so that is the answer to the first part of this problem, which is, what is your monthly payment? Of course you can, Miss Daniela, you can always watch the recording afterwards. Make sure that you mark it as reviewed after you watch it. Okay, so that's the first part of this problem. The next part says, how much of your second payment is interest? Well, that's interesting, right? Because the only way for us to know that information would be to build an amortization schedule. And so this is kind of like part 2 of this lecture. We're going to get more practice. I'm going to try to get as many practice problems in as I can during this hour. But this is really neat because a lot of students don't know how to do this. Okay, so to build an amortization schedule, the first thing that we need to do is we need to develop some headings. So we have our payment, like payment number, if you will. So let's make this a little bit bigger. Let's do that. Okay, we have our principal. Maybe we want to say, let's go beginning principal. Okay, we have our, let's see, maybe we'll call this month so we don't get confused. And then we'll call this payment because we'll represent the payment in dollars there. Okay, and then we know that every payment is going to be the same. However, we need to know how much of that payment is interest, and we need to know how much was principal that was paid. Okay, so when we have an amortization schedule, what's happening is, your lender used the time value of money function to figure out what that equal payment needs to be to pay off all principal and all interest throughout the life of that loan. But what this does not tell us is how much of that payment is interest and how much is principal. That's where the amortization schedule comes in. Okay, and so what we're going to do is we're going to learn how to figure that out. Okay, so we know there are 120 months total. So in Excel, you need to get at least 3 or 4 lines down before Excel can see that you're creating a pattern, a mathematical pattern. In this case, I'm counting 1, 2, 3, 4, 5. So after I get through 1 through 4, it should pick up on it. So let's see, 5, 6, 7. Yep. So it's picking up on it. I'm holding that corner down with my mouse, and I'm just going to drag it all the way down to, I see it's a 120. So I'm going to get all the way to right there, and I'm just going to stop. So that's 120 lines down. Okay. And then I know what my beginning balance is, right? My beginning balance is the $30,000 that I took out. Okay. And I also know my payment. My payment is $380.03 because I just calculated that. Okay. And then my interest, this is where it gets a little tricky. So the interest is the periodic rate or monthly rate multiplied by the beginning principal. So this is really neat because we get to use cell referencing. So we're going to say equals. We're going to grab that principal. We're going to say times. And we're going to grab that monthly rate right over there. And then in Excel, if we're going to try to duplicate this row over and over and over again, which is exactly what we're going to do, we're going to anchor this interest rate because this is our data table. These are constants. They don't change. And so I'm going to anchor that like this by putting dollar signs in front of the C and in front of the 7. It might not be C7 on your Excel spreadsheet. It might be a different cell reference, but still you want to put your dollar sign in front of the letter and the number of the cell that this is sitting in. And then you want to hit enter. Okay. And so what this tells me is that of the $380 that I spent in my first monthly payment, $225 of that payment is interest. It's just pure interest, the cost of borrowing. Okay. And so the question then becomes, well, how much did I pay towards principal? Well, it gets a lot easier once you know how much interest you're paying. You can say, okay, well, I know that I made a $380.03 payment, and I'm going to subtract the amount of interest that I paid during that period, and the remainder is what went towards principal. So in that first payment, I paid $225 to interest, but I only paid $155.03 to principal. And so since I did make a small payment towards principal, my principal changes. So I also have to figure out what my ending principal is. Okay, so I'm going to say equals. I'm going to take that beginning amount and I'm going to subtract what I paid towards it. And so now my ending balance is $29,844.97. And so since that's my ending balance, it just so happens that that's also my beginning balance for the second period. So I'm just going to go down to row 2 and equals and grab that cell. Okay, and this is where it gets really simple, because what we're going to do is we're just going to start letting Excel learn our formulas. So I'm just going to grab this and drop it down. Okay, I'm going to grab this one and drop it down. And because I anchored, look at what it did. It took J14, which is sitting here, my beginning principal. And if you look at my formula there, it multiplied it by the rate. I didn't have to recreate that. The anchoring told it to look to the left in the exact same place that this one was looking to the left. So it copied down a row, but it looked right where I wanted it to. And it also looked back to that monthly rate, which is really neat because I anchored it there. So no matter how many times I copy that formula, it's always going to look back to that anchored cell there. So that's pretty cool. Then I'm just going to drop this one down one time, and you can check that there. So you always want to kind of check at the beginning to make sure your formulas are copying down correctly. So this one says K14 minus L14 for me, which is this amount minus this amount, so it's working perfectly. And so then I'm going to go here and drop that down. And so let's see if that one worked. Yep, J14 minus M14. So everything is working really good. So I'm just going to keep progressing to see if it's working. Looks like it is. Okay. I'm going to do it one more time just for safe measure. Looks like everything's working properly. And once I have 3 rows, I should be able to grab this, like highlight, you have to highlight all 3 of them. And I'm going to grab this corner, and here's hoping Excel likes me today, because if it does, I'm going to drag it all the way down to that 120th row. And this looks pretty accurate. So what's going on here is there's a slight overpayment of 52 cents. What that tells me is that the rounding that was done here to get this 3 cents, it just meant that at the very end it was slightly off, and that can happen with an amortization schedule. There's nothing to worry about. If you ever get an amount that is extremely close to 0, sometimes it might come up slightly over 0 or slightly under 0. But if you get extremely close to 0 or 0 on the dot, which is what we hope for, then you know your amortization schedule worked properly. If it comes up way off, so like if you get down here and this last bottom right cell is some big number, then you need to go back and check your formulas. And you can undo what you just did by hitting Control Z or Command Z. Or some of you might even have the undo arrow up here on your ribbon. Okay, so but you want to pay attention. And even though this problem only asks about the second payment, filling out the full amortization schedule and looking at this bottom right cell tells me whether or not I did a good enough job at creating my amortization schedule properly. So now what I can do is I can go back up and I can start to look at this. And this is really neat for anyone who is not familiar with how an amortized loan works. So you'll notice that the payment stays the same every single month. But what you should start to see here is that every single payment is represented by a different amount of interest, a different amount of principal. They are never the same. And at the beginning you should have learned this last week in one of your classwork exercises that we did, because it was one of the questions. At the beginning of a loan, interest outweighs principal. But as we move through the loan, you start to see them converge, don't you? See, look here. See how they're getting closer and closer together? And it's because you're paying down that principal. And as you're paying down that principal, the interest rate is producing a smaller and smaller amount of interest until at some point they actually converge. It looks like they converge right here around month 30, 31. Suddenly, right in here, where are we at? Right here's where it flip-flops, right there. So in month 28, we're still paying slightly more interest than we are principal. Then in month 29, it flips, and now we're paying less interest and more towards principal. And once we start doing that, you see the interest side of the equation gets smaller and the principal side gets larger until we get all the way down to the bottom to where those that year or two of payments is almost no interest and almost all principal, right? And so this, 1 second, Ariel. This problem asks how much of your second payment is interest. Well, it's very simple. Once you have a amortization schedule, we can literally go to row 2 and look for our interest column, and voila, that would be the answer to that problem right there. What's your question, Ariel?
I was gonna say, isn't it true that whenever the interest gets smaller than the principal, that you're getting closer to the end of your period?
Yes,
Pay period?
that's right. That was one of the questions on last week's little worksheet that we did about reading the fine print. I think one of the questions talked about that. You can actually look at a mortgage statement and you can look at the payment history and actually determine where a borrower is at in their loan just by looking at how much principal versus how much interest they paid on their most recent payment. You can actually, you don't know exactly where they are, but you can tell whether the interest outweighs the principal or the principal outweighs the interest where they are in their loan, which is pretty neat. Any other questions? Was everybody able to duplicate what I did here?
I had one question as far as the end principal,
Okay.
because I know for the interest you multiplied the present value and then times the interest rate, but you did something in particular with the sales. But for the end principal, what is it that you were subtracting?
So the end principal is the beginning principal minus the principal paid. So if you think about it, this payment is comprised of these two things. The interest paid and the principal paid equal that payment. So these two columns added together will always equal this column. And if you think about it, your interest column is literally the cost of borrowing. So it does not go towards your principal at all. It is the fee that you as a borrower agree to pay to borrow money. So another question that I often get is, well, how much interest did this borrower pay? Well, there's a fast way and well, I mean, I think when you have an Excel spreadsheet, they're equally as fast, but there's two methods for figuring that out. You can either go to the bottom of your interest column and you can just do a sum formula. So you can go all the way to the bottom down here. Oops. And you can say equals sum, which is just going to add up all the numbers that you're giving, the formula. And I can grab every cell in this column. Okay. And then I can close parentheses and hit enter. And so the borrower, let me put it in dollars so that you can see this. The borrower is paying $15,000 in interest during the life of that loan. Now, let's remember that we are only borrowing $30,000. So for you math savvy folks, quick math tells us that means that the borrower is paying 150% on the loan, right? Because they're actually paying $15,000 in interest, which is 50% of what the loan is worth to them, on top of the principal that they had to pay back. Another way to figure that out without having to create an amortization schedule is once you find your payment, you can multiply that payment by the number of payments or months, right? So I can actually say my payment of $380.03 times 120 payments. That tells me that during that 10 years, I'm going to pay $45,000 back to the bank, even though I borrowed 30. And then if I want to know how much of that is interest, all I have to do is take that amount and subtract the 30,000. And you should get the same answer. So that's two different methods to find the same answer. This actually came up over the weekend. I had a student who is evaluating her options to buy a vehicle. And she and her husband were originally considering getting a used vehicle. They were looking at something around a 2015 or a 2016. And they were looking at the financing options, and they came to me and they said, well, there's these dealers that have these deals right now for 72 or 84 months financing at 0% interest, which literally means there is no cost to borrow. And so I was able to sit down with that student and her husband and actually walk them through how to do just this and to determine the cost of borrowing. And obviously, the newer vehicle is going to cost them a principal difference of about, I think it was like around $10,000. I think the used vehicle they were looking at was around 21,000, and the new vehicle they were looking at was around 30,000 before dealer fees and all that. But then we determined that even with the low interest rate they were being quoted for the used vehicle, I think it was about 3% interest. We determined that she was going to pay around $5,000 across the term of that loan in interest, which made the used vehicle $5,000 more expensive. And so if we add that 5,000 to the 21,000 that the vehicle was listed for, it means the true cost of the vehicle is $26,000. Well, when you look at it like that, and then if you all think back to our automotive chapter, when we talk about the cost of ownership, right, of a used vehicle, and we start looking at maintenance, we look at like, are we going to have to replace things like rotors, brakes, and is the vehicle still under warranty? If it's not, then that's an additional risk. They started to realize that, hey, maybe the brand new option isn't such a bad idea because we're not paying anything to borrow it, right? To borrow that money. It's 0% financing. And on top of that, we're getting a vehicle that is covered bumper to bumper for a certain number of years, so we don't take on additional risk. That was a really neat conversation. I always like to be able to help students out in real life situations, but we used exact math just like this to be able to have that conversation. Pretty neat, huh?
Yeah.
Okay, well, let's try to get another practice problem in. So all I'm gonna do is I'm just gonna click this little plus symbol down here and open a new workbook. Let's just go ahead and make that bigger. All right, and here's another problem. This is very similar to the ones you're gonna see on your little homework quiz. There we go. So John and Peggy recently bought a home. They financed the home with a $125,000 30-year mortgage with a nominal interest rate of 7%. It tells us to assume monthly compounding. How much will their mortgage payment be? Then it says using an amortization schedule. How much principal will they have paid after 5 years? How much interest will they have paid after 5 years? If they decided they wanted to pay off the loan in full after those 5 years, how much they owe? So this is very similar to what we just did, right? It's just more practice, okay? So remember, the first thing we need to do is to define our variables, right? Create that data table, okay? And so we have N, I over Y, PV, PMT, FV, right? And so let's go back through that problem and learn, okay, what are we being told? It says they financed the house with a $125,000 loan. So that's going to go right here, right? that is our present value. It says that it's a 30-year mortgage. So this right here, we're going to type in 30 years just for now. It says to assume monthly compounding. So I'm just going to come out here and say M equals, 12 months, right? Because M is just the number of compounding periods, or we'll say in this class, we'll just say A periods per year. Man, my thumbs must be grabbing that trackpad a lot today. Per year. There we go. So M would be 12 months in this case. Okay. And it says our nominal interest rate is 7%. Remember to convert to that decimal, 0.07. Or look at the payment, and like we said in the last problem, we know that the future value of the loan should be 0, right? So just like in the last problem, we have to make a couple of modifications because nominal interest rates are annual percent rates, and we're also given in years, but then we're told that we're making monthly payments to assume monthly compounding. So for N, I need to change that from 30 years. That's right, Tristan. We're going to multiply it by the 12 months per year, and that's going to give us 360 months or payments, okay? And then the annual percent rate must also be converted. So we're going to say 0.07, and we have to divide that because it's an annual rate. We need it to be a monthly rate, right? Because it's a periodic rate that we're looking for. So we're going to divide that by 12. And so that's going to give us our monthly or periodic rate, okay? The present value stays the same, it's in dollars. The future value stays the same, it's also in dollars. So now we just need to find our payment. So we're going to say equals payment. And we're going to give it the information it's asking for. Just by cell referencing, remember, we're just clicking cells, just giving the formula what it needs. And then, like I said before, you might want to just put a little minus out in front of your payment formula to force it to be a positive value at the end. And then hit enter. So this is the first part of the problem. How much will their mortgage payment be? Well, mortgage payment's going to be $831.63. Okay. And so it says then using an amortization schedule. Well, let's speed this up. If you have Excel open, let's hop back over to sheet 1 and let's just grab those headers. So I'm just going to grab these headers right here. Okay. And I'm just going to copy, and I'm going to hop right back over to this sheet. Okay. And I'm just going to drop them in where I want them. Okay. And you might need to format because they're not going to be the same width. There's a quick way to do that. You can go to format and then do auto fit column width. And voila, that forces them out a little bit wider there for us. Okay. And we know that it's going to be 360 payments. So we'll just do a quick 1, 2, 3, 4, 5. And then, I'll take that and I will drop it all the way down to 360 lines. Wherever you see that little box there, you want to stop at 360. There we go. And then I'm going to come right back up. Okay. And then just like before, we're going to have a starting principal of 125,000. We know our first payment is $831.63, right? And then this is where we start to do a little bit of math. We're going to say equals that beginning principal times the periodic rate, and we're going to anchor that rate. Okay? That's going to tell us how much of that first payment is interest. Then we're going to take the payment and subtract the amount that we paid towards interest. So now we know the amount that was paid towards our principal. I'm going to shorten this to two decimal places because it is dollars and cents. And then to find that ending principal, I'm going to take my beginning principal and subtract what I paid towards principal. And so that is the new account balance. There we go. And so then at this point, we just start to let Excel do the work for us, right? So we're going to say equals, the beginning balance is the ending balance from the previous period. Okay. And then after that, we just start dropping these cells down because we're going to let Excel do the work. We want to do that at least 3 times over, remember? So we're going to go one cell at a time, just for a few rows. So that way Excel can learn our formulas and understand what we're telling it to do. Okay. The formula for interest is you cell reference. So you want to grab your beginning principal by cell referencing it, and then you want to multiply by the monthly rate, which is in our data table, and then you want to anchor it. So you want to put a $ in front of your letter and 1 in front of your number. Hopefully you can see that there. And what that does is that no matter how many times we copy the formula, it's telling the formula to always look 2 cells to the left for the principal. But it's also telling Excel to look to the data table for the interest rate, because the interest rate does not change. The principal does, but the interest rate never changes. Remember, this is a fixed rate. That's all we're dealing with today. Today is Wednesday. We will be dealing with adjustable rates. So we'll learn how that impacts this amortization schedule. It gets very tricky. Okay, so I'm 3 rows down. At this point, Excel should understand what I'm doing. And so I'm going to highlight all 3 rows there that I just created. And then I'm going to grab that corner. I'm just going to hold my mouse and I'm going to go all the way down 360 lines. Okay, I'm going to let go. And once again, it looks like we have a slight overage, but that's probably just a rounding error. All it is it just means that at the end, this last payment would have just been adjusted off, and that is what most lenders would do. Most lenders, if there's an odd number that's forcing like a couple of pennies every month to be off, what they'll do is that last payment, when they see that overage, they'll subtract it from that last payment. So on a real amortization schedule, what would happen is we would go to that last payment there and we would say equals, we would say minus 2.29, enter, and then that last payment would just be slightly less than every other payment we've made, and that's how we get that ending balance there. Just so you all know, you shouldn't need to know that for any problems in this class, but this happens all the time. It's a rounding thing. And so that's how it's typically handled at the very end, is you'll just have one payment that's slightly smaller. Okay, and then the question, so now we've created our amortization schedule. And let's go back to our question. So our question says, how much principal will you have paid after 5 years of payments? So it wants to know how much principal has been paid. So I'm just going to come right over here. Now remember, it says 5 years, not 5 payments, 5 years of payments. And our payments are not in years, they're in months. So it's asking about 5 years times 12 payments a year. So we're actually looking at payment 60. Okay, so we need to go all the way down to payment 60, which is right here. Okay, and it's saying there's 2 different ways that you can figure this out. It's saying how much principal have you paid. You can either, now this gets a little tricky because remember, it says at the end of 5 years, so that's not going to be the start of this row. It's going to be at the end of the row, right? The ending balance. So it's the ending balance of payment 60 or the beginning balance of payment 61. They are identical. It does not matter which one you hone in on. Okay, so there's 2 different methods for finding that answer. You can either take your beginning principal and subtract your ending principal at the end of payment 60. So, our beginning was 125,000, and you could just subtract our ending balance right there. Do you want to accept this correction? Oh, it doesn't like, I don't know why Excel does that. It doesn't like commas sometimes. So it's just taking my comma out of my formula. And so I have paid about $7,000. Across 5 years, I've only paid $7,000 towards my principal. That's one method. The other method is to use a sum formula, and they should produce the same answer. So you can use a sum formula, and you can start at the top here, principal paid, and you can grab every single cell all the way through payment 60. It's in that column. So right to there, and then close, and you should get the exact same answer. So that's two different methods to find the same answer. It's just whatever one you prefer to do. Everybody likes to do math a different way for some reason, but we all have our, our little, you know, habits that we like to stick to. So whichever way you like to look at that math is fine. So that's answer one, is how much principal have we paid, right? And it says how much interest will you have paid after 5 years? Well, again, we would probably want to use a sum formula. We would want to start right there. So I can go, it doesn't matter where my formula is, I can go sum, okay? And so I can grab right there and just go straight down my column to payment 60, which is right there. And then close parentheses and then hit enter. And so I have paid $42,000 in interest at that point in time. So let's do a side-by-side comparison. Kind of scary. So by the, oops, nope, let's try that again. Hold on. Let's go, it's trying to copy my formula instead of my value. So sometimes you have to tell how to paste. And so I don't want it to bring the formula, I just want the value. There we go. So in 5 years' time, I borrowed $125,000 5 years ago. Across those 5 years, I've only paid $7,300 towards my borrowings. I have paid $42,000 to the lender. That is simply the cost of borrowing. None of that money right there goes towards my principal. That is simply profit earned by the lender. Okay, so this is total interest through 5 years. This is total principal paid during those 5 years. Okay. And then the last question says, if you decided that you wanted to pay off the loan in full after those 5 years, how much would you owe? Well, that's simply that ending balance at line 60. So that is that amount right there. So if I wanted to pay that loan off after 5 years, I would still owe $117,664.35 to pay my loan off. That would be my payoff. And I think that's all the time we have. I actually believe I ran over by a few minutes. Don't worry, we've got more practice problems. This is all we're doing this week, is just learning how to use time value of money, learning how to compute all these different types of scenarios. So we're going to do even more of these on Wednesday. And we're also going to learn the difference between a fixed mortgage and an adjustable rate mortgage and how that impacts this schedule that we have learned how to create today. Okay, that's all I've got for you for today, folks. So I really appreciate you all working with me today. And as always, you're a great class, and I will hang back for a few minutes for anyone who has any questions. I do have another class that starts in 5 minutes. Thank you.
Take care.
Mm-hmm.